one is a troublemaker, this one is another. Okay? So I know, now I know for high cutoff, there are 4 troublemakers, and this one, it doesn't matter. Okay? So what's the next step? Now I only know which capacitor will contribute to this cutoff. What's the next step? My final goal is to find the exact cutoff frequency, right? I want to calculate. So now I only know which capacitor is the troublemaker. So how should I proceed?
Find the resistance.
Find the resistance of?
Seen by the...
Before that, there is one step you need to do. Before that. Now we already know all the troublemakers. So in order to find my cutoff, what's the next step? It's a very small step, but you need to remember.
Short those capacitors down.
Short all those helpers. Because you cannot just leave them there, right? I mean, how you are going to treat this capacitor? Okay? So for the helpers, because they are not contributing to my frequency drop, so we can safely short them. Right? That means after I short these helpers, my gain will not change much. So I can safely short them. I don't need to consider too much. So I can just short my CC. Then we can find the resistance. What do you mean by find the resistance?
The resistance seen by...
Yes, what's that sentence mean? It's written inside your notes. Find the resistance seen by... Find resistance Ri seen by Ci. What's that sentence mean? What's the meaning?
They want the resistance for the rest of the capacitor.
No.
They put a test voltage at the capacitor.
Okay. It is a correct method, but can I make it simpler? I mean, if you put test voltage, then you are doing the small signal analysis, right? I mean, for the small signal analysis part, if you want to find the V in, if you want to find the R in and R out, you put test voltage, right? I still feel it's a bit troublesome. Is there a simpler way? Basically, what's the basic idea of find Ri of Ci? Find Ri seen by Ci. What's the meaning of this sentence? What do you mean by Ri seen by Ci?
Resistance of capacitance.
No, it's not. It's not resistance of capacitance. Never confuse your Ri seen by Ci. Never confuse your Ri with the resistance of your capacitor. What's Ri seen by Ci? What's the meaning of seen by Ci? Yes. Between the terminals of capacitor, then?
Total resistance basically with reference to two terminals.
Yes. Basically, it means that because my capacitor got 2 terminals, right? This 2 terminal is going to connect to external circuit. Right? So resistor seen by Ci, let's say this resistor is a Ci. So resistance seen by your Ci, which is Ri, is basically here. You stand here, then you face here. You face the circuit. Then you try to summarize what's all the resistance seen.
Then like Thevenin.
If you have a resistor in between those terminals, then how would you compare?
Then you just move your circuit. Circuit can be moved.
As in between the two terminals where you're pointing at Ri now, if there's a resistor right smack in the middle.
What do you mean by resistor?
I mean, if there's resistors at the sides, I can sum it out all up, right? No, as in the main loop.
The main loop?
arrow is right. That loop everywhere can have
Yeah.
resistors.
Is
Yeah.
it?
So that one is
It's
very
the same,
important.
right?
But what happens if there's one something like
Let's say here is R1, here is R2, here is R3. What's the total resistance seen by my capacitor?
Ask question then you don't.
so what between the
Yeah, then you go
two
question you push them. Then you listen people. So much easier to talk.
this side.
So
So
what
what
happens
happens
if
if
people
there's
come
a resistor right smack in the middle here?
What is like smack in the middle?
If let's say I have a resistor here,
You
how am I supposed to calculate?
Easy to push, is it?
How you are going to connect
People
resistor
ask
there?
question, then it's
I just want to ask where are the two terminal go?
much better.
Connecting to where? If you resistor,
Okay, if let's say
cannot just
if
go.
let's say it's connected this way,
this
Okay.
then how would you
So that means now I'm having resistor this way.
Then you ask. Yes.
Maybe that's the last time. Of two.
Right.
People ask really that and ask us.
So what's the total resistance seen by my CI?
Other people ask the
I want to
side one.
The sum of these three resistors.
Side one. 2067. Side one.
Correct.
The paper one is very hard.
But what if I cannot form a hello? What if I cannot form a complete loop? Let's say got some break here. The circuit breaks here. What's the total resistance seen by my capacitor?
R1 parallel R2.
R1 parallel with R2, right?
oh yes,
Right?
okay, both same voltage.
Because I'm treating this whole thing as one node. Okay? That's the meaning of finding RIC by CI. So basically, now I need to find what? All the RIs, right? So if I want to find the resistor seen by my CGS, what's the resistor? Total resistance? What's the total resistance seen by my CGS? That's called RGS. What's the total resistance?
Replace it with a test voltage.
Is it like
RG plus
One question now. When I am finding the RGS for this CGS, how should I treat other troublemaker? I know the helper, I can just shut it. How about other troublemaker?
open?
Open, right? I just treat them are not there. I just assume they are not there. Okay, so I only look at my CGS. So what's the RGS?
R6 parallel RG plus RL.
R what?
R6
R signal
plus parallel RG
parallel with RG
RL
plus
RL.
RL. Is that correct? Is that correct? You still got one more resistor here, RD.
Is RL parallel RG?
I asked you whether RL is parallel with RD. You tell me. RL and RD, they are parallel, right? Because this terminal they are connecting together, and the other terminal they are also connect together. Both are ground. So it's basically RL in parallel with RD. So that's your RGS. Is that all? Is that all? Is that all? Aisha.
I think you are not.
Is that all?
I think you assume R naught is
I'm assuming what?
R naught is infinite, is it?
R is infinity. Where is my R out? R out. When we talk about R out, we are talking about what? you need to remember between D and S of your MOSFET, there is always a R out. If you draw the hybrid pi model, there is a R out between the D and S, right? Okay. So is that R out going to be counted for this case?
Oh, I shorted it. Is it shorted?
Is my R out included in the loop seen by my CGS?
It is not.
Why?
Because the CGD is open, right?
Yes, my CGD is open.
Between gate and drain also is open.
Between gate and drain is also open.
Remember correctly.
Okay. So
No current.
So basically you are talking about this one. Here is my drain, here is my gate, here is my drain, here is my source. Here is my R out. So my source is connected to the ground, and here is my V in. And here I got R signal and RG. So your CGS is actually here. Here's the CGS. So what's the resistance seen by my CGS? One is these two in parallel. One is whatever on that side, right? It's RL, parallel with RD. So how about this R out? Hello, how about my R out? Is it going to be included?
Yeah. Yes, included.
Or why it is not included in the notes?
Because it's an assumption.
I mean, we just draw accordingly, right? We just draw accordingly and we get this result, and we can see clearly this RR is there, right? It is actually in parallel with my other two resistor. So theoretically, I should include that, right? But why inside the notes it is not included? I think inside the notes, you're using the new notes or old notes?
It's included.
Same.
Oh, it's the same, right? Huh?
It's roughly the same.
The CGS doesn't even include this. RD and R is not.
Yeah. That's true.
Why it is not included?
Actually, RL and RD also not included.
Why? My question is why? Inside the notes, your notes even ignore this part. Why? Why? Where is not connected?
The CTS is not connected to that side.
Why?
The sensor part is not connected already.
Why? Yes, it's not connected. Why? Explain to your friend. Explain. How to see? Why you say it is not connected?
What's with CGD is open?
It is because what?
You remove everything, you only short the CC, right? So the CGS technically is not there. It's empty.
See again?
And then it's like the capacitor that the CGS can remove.
CGS is not removed.
I don't remember.
CGS is the troublemaker. Now I want to find the resistor seen by this capacitor.
which we open
So basically
the
we are
CGD.
no, wait a minute. Now we are not removing capacitor, we are not shorting capacitor. Okay? We already find the troublemaker. Removing and adding and shorting is only for you to find the troublemaker. After you find the troublemaker, the next step is to find the resistance seen by each troublemaker capacitor. So now we are not removing, now we are not shorting. We are just trying to see what's the resistance seen by each of my troublemaker. So now let's say I want to find the resistance seen by my CGS first. So now you tell me what's the resistance seen by my CGS, that's all. But because I got more than one troublemaker, other than CGS, I still got other troublemakers, right? So in order to simplify the question, we use superposition idea. I just treat other troublemaker and not there first. I only consider this CGS. I only consider this whole circuit only got one troublemaker, which is my CGS. Then I try to see what's the resistance seen by this CGS. So what's the resistance seen by my CGS now? Just now you mentioned it's not connected. I'm asking you where it's not connected. It is not connected. It's true, yes. Where?
CGD.
No. We are talking about CGS now. So all other capacitors are not there already. Although I didn't remove them, they are not there already. Okay? You only got one CGS, that's all. So what's the resistance in my CGS?
It's only by that side.
Yes, it's only on the left hand side. Why? Which part is not connected?
The CGD, the gate,
We don't have CGD already. We don't have other resistor already.
no, the gate is not, because this one is a MOSFET.
Okay.
And the gate is not connected to the.
Yes, the gate is not connected to your DNS, yes. But now what I want to say is, because just now you mentioned CGS is not connected to the right hand side. I want to ask you which part of your CGS is not connected to the right hand side? Yes, the CGS is isolated from the right hand side. Yes, that's correct. But where? Okay? If you see this part, you draw your circuit this way, right? If you draw your circuit this way, because these two terminal both are connected to the ground, so it looks like these two parts are actually connecting together. But actually it is not, because these two, I can just separate them and draw a separate ground for them, right? That's the basic trick when you do your single transistor amplifier. Right? I mean, when you do a single transistor amplifier analysis, you sometimes you encounter this situation, and then you suddenly realize, oh, I can actually separate because both of them are connected to the ground. I don't need to connect these 2 points together. There's no point to connect these 2 points together, and even they are connecting together, they are separated. Okay, so now your CGS is here because the CGS is this terminal is connected to the ground. So the CGS is here. Basically, it's only on the left hand side. So it got nothing to do with the right hand side. So what's the resistance seen by your CGS? It's only your R signal in parallel with RG, right?
How do you know when to split and when not to split?
No, if they are sharing the same supply, let's say if these two terminals are sharing the same VDD, you don't need to connect these two terminals together. You can just write one VDD or one VDD shield. And ground is also the same way. That's why, hello. That's why when doing the small signal analysis, I don't like to draw circuit this way. I mean, connect everything like by one horizontal line together. What I usually do is I just break the line and I just put individual ground here. And erase. You don't really need to draw out the small signal equivalent for this one, because you can directly see from this graph, your GS is connected to the ground, so it got nothing to do with the right hand side. Can you erase? So next, let's find the resistor seen by your the output side, the CL and CCTV. These two capacitor, they are easy because they are in parallel. So whatever resistor seen by your CTV will be the same as whatever resistance seen by your CL because they are in parallel. Basically, no matter how you see, what they see are the same now. Okay, but you cannot just take one value. I mean, you need to consider both resistance. Okay, so what's the resistance seen by CTV? We call it RDB. RDB equals to
RL parallel with RD and R naught.
RL parallel with R what?
RD.
RD. R naught.
RD and R naught. R naught.
This kind of analysis method, which means that we don't really draw out the small signal equivalent circuit. This kind of method is the most usual way when we do circuit analysis. Because usually when you design a circuit, you don't really need to know the exact value. I mean, you don't need to calculate the exact value of the gain of the system. Because you do circuit analysis, you're using computer, right? Your computer simulator will calculate everything for you. But when you are trying to design a circuit, you need to roughly know what's the gain and what's my resistance. So this is actually the usual way we use. So this is the common way. The before part, the small signal, whatever, all those complicated calculation is for you to practice. But when you do a circuit design, it is actually we are just looking at the circuit. But you need to be very familiar with the equivalent circuit. I mean, you need to at least know there is a R, right? You cannot just, So RDB is actually RL in parallel with R out in parallel with RD. Can you see that? No problem. This part is straightforward, right? Okay. Just one capacitor. And by the same token, your R with RL, I mean RCL, the resistor seen by your CL, will be RL in parallel with RD in parallel with RL. Okay, so how about this CGD? Usually CGD is the most troublesome one. CGD. I mean the resistor seen by your CGD. Usually this one is the most troublesome one.
They see both sides.
They see both sides. Why? Why you say that? Because if you can imagine, here is the small signal equivalent. Originally, the left hand side and right hand side, they are separated. Your gate and source and drain, that side are separated. But this capacitor is linking them together. So they see both sides. So this one is the most troublesome one. So how to find this RGD?
Put a test voltage.
Yes, you can put that, but it will be trust. This part is actually, if you do a lot of circuit analysis for your single transistor amplifier, the idea is actually coming from your common gate amplifier, CG amplifier, if you still can remember, the non-inverting amplifier. The output resistance of your CG amplifier. The resistance seen by your CGD is actually the output resistance of your CG amplifier. How you find the output resistance of your CG amplifier is basically, you can use the same method here, and you will find the same result. So this part, if you want to see the full analysis, you go back to see how to find the output resistance of the CGD. Now I'm telling you, because after you do the circuit analysis, you will realize that the outcome is always the same. I mean, got some certain pattern. So this CGD is usually the output in the resistance at the input side plus the resistance at the output side times GM times the input side and output side resistance. So it is usually how to say, R signal parallels RG. These two are at the input side. These two are at the input side. So we consider them as the input side resistor. Okay? So these two is this one is the input side resistor plus the output side resistor. What's the output side resistor? RD parallel with R naught plus GM times both sides. So it's basically GM times R signal parallel with RG times RL parallel with RD parallel with RL. That's the pattern I mean for this RGB. You can do your full circuit analysis to find this result. And the circuit analysis is in your CG output resistance part. You can go back and do your revision. So we finished, right? We got 4. Because we got 4 troublemaker and we got 4 resistance. So we finished. So what's the next step? We finished this step already. We know which one is the troublemaker. We know what's the corresponding resistance seen by all these troublemakers. What's the next step? Final step is to? Yes. The final step is actually to find my high frequency cutoff, right? High frequency cutoff. Omega what? This step is easy. Why? Because it's just a summation of all my Ri times Ci. 1, 2, or whatever. 1. So if you write out this equation, it's basically RGS times CGS plus RDB times CDB times RL plus RL times CL, then plus CGD times RGB. That's all. You just plus them, times them together, then plus them together. Then put them as the denominator. That's all. Then you get your high cutoff frequency. This method is fast because it doesn't really require you to do the full circuit analysis. You can just see all the capacitor resistor from the circuit. Then you can just calculate an approximate number. So this is how to find a high cutoff. How about lower cutoff? Can you raise? All these are inside the notes, huh? All these are inside the notes. It's inside the notes.
Yes.